So, good morning, everyone. Welcome to one more session of the training of Ways to Be a Com project. Today, we are going to start the third session of Ways to Be a Com training activities. Today, we have a lecture, and these sessions will occur because CITEV is planning to do these sessions. CITEV is the Technological Center of Textiles and Clothing of Portugal, and we offer numerous services, testing, product certification, research and technology development, engineering, sustainability, which is one of the key topics that we are also going to talk today, fibers development, the training, and also this part, innovation and consultancy, also in different market-oriented sectors like fashion, sports, mobility and transport, defense, workwear, health, architecture and construction. So everything and everywhere textile is. So for today, we have alternative fibers lecture. And I will present you Lucia Rodrigues, which is a colleague of ours here in CITEV. And today I will pass the floor, the digital floor, to Lucia to present us what are the innovations in the fibers and sustainability. Thank you very much for being here, and I'll be back in the back if you need anything, and please don't hesitate if you have some doubts or if you want to answer or if you want to question something. So please, Lucia, I will.
So good morning, everyone. Just a second, just to share my screen. Okay, is it okay? Are you seeing? Okay.
Yes.
So first of all, thank you all for participating. This session is organized into parts. The first part is a brief overview of the classification of the textile fibers, the global market, and the main technological innovation approaches. The second part is dedicated to concepts, the main concerns related to the textile fibers and the main key factors to answer to these concerns. At the end of this webinar, I will identify some examples of recent fibers developments with sustainability and circularity criteria and the categorization of materials defined by a well-known brand. So these are the topics regarding the first part. And here in this slide, we have a scheme that summarizes the classification and origin of the textile fibers. So fibers can be classified as natural or man-made based on their nature and their origin. Natural fibers come from plants, animals, or minerals. Plant fibers can be also categorized according to the part of the plant from which they are extracted. These categorizations include seed fibers, which comprise cotton and kapok. Other bast fibers include flax and hemp and also rami. And the leaf fibers that is here represented by sisal is another characterization. Also, coconut is obtained from fruit of the plant. Animal fibers include wool, cashmere, alpaca, mohair, and silk. And the mineral fibers include asbestos, which is not used for healthy safety reasons. Basalt is obtained from the volcanoes lavas. Man-made fibers are produced by men, but they also can be classified according to the nature of the used polymers. These fibers can come in continuous filaments or staple fibers. The staple fibers can be further spun into yarns or used in fillings or nonwovens. Natural polymers-based fibers can be obtained from different sources. Cellulosic materials, they are also called regenerated or modified fibers, depending on the production process used to obtain these cellulose-based fibers. Lyocell, viscose, and modal are examples of regenerated cellulose fibers, and modified cellulose fibers include cellulose acetate and triacetate, for instance. Regarding synthetic fibers, these fibers are obtained from synthetic polymers, which were produced by chemical synthesis. Petrochemicals are the most common source to produce these fibers. And recently, we have been facing a big effort to replace this source by other biosources, such as plant sugars, as we will see at the end of the session. Synthetic fibers can also be subdivided into organic and inorganic categories based on the chemical nature of the materials and their biodegradability capacity. Polyester, polyamide, polypropylene, aramide are examples of organic fibers, and metallic and glass fibers are considered inorganic, and they are used in composites as reinforcements. In this slide, we can see the global market for textile fibers in the last 2 years. So in 2023 and 2022, this These figures were published by Textile Exchange. And as we can see, global fiber production increased in 2023 compared to 2022, and is expected to grow in the coming years. As we also can see, the synthetic fibers accounted for approximately 67% of the world's fiber production in 2023. In fact, polyester had the market share of around 57%, which means that remains the most produced fiber. Globally, the production of recycled polyester fibers has increased, but due to the increase in production of virgin polyester, there has been a decrease in the global share of this fiber. Polyamide is the second most used synthetic fiber and accounted for around 5% of the global fiber market in 2023. Plant fibers had a market share of around 25% in 2023. Cotton is the second most important fiber globally in terms of volume and had a market share of approximately 20% of the global fiber production. We can also see that global plant fiber production slightly decreased in 2023 when compared to 2022. The production of man-made cellulosic fibers accounted for 6% of the global fiber market in last year. Viscose accounted for around 5%, so it's the biggest that has the higher production. The market share of man-made cellulosic fibers decreased slightly compared to the previous year, but the production volume of these fibers increased. Even they are not represented in these figures, I can say that the market share of man-made cellulosic fibers made from recycled feedstocks increased in last year, and it is expected to increase in the coming years thanks to the ongoing research and development on this subject. Animal fibers had a combined market share of 1% in 2023, so is the lowest share of the global fibers production. It is also important to highlight that less than 1% of the global fiber market came from pre- and post-consumer recycled textiles, so it's a very low quantity yet. And now, which are the main innovation technological approaches in the fibers world? We know that for specific applications, textile performance is the most important issue. I'm referring, for instance, to technical textiles. For example, personal protective equipment, sports, automotive, medical, and so on. And in these cases, synthetic fibers can be designed, can be produced to provide the properties required for a specific end use. For some examples that I bring here today, it's possible, for instance, to improve thermal insulation, breathability, using special synthetic fiber cross sections. Is it possible to add functional additives to provide specific functionalities? Is it also possible to combine polymers at the same fiber cross section? Um, it's also possible to develop novel polymers and fibers, and it's also possible to do fibers combinations. So I think everyone agrees that performance is and will continue to be a very important driver in fibers innovation. So mainly, I would say for technical applications. In addition, or on the other hand, in order to be aligned with the European Union regulations, frameworks, sustainability and circularity, especially in the fashion industry, are no longer an option. So I think it's must a kind of must, more and more an obligation. So the exploitation of materials from renewable sources, meaning fossil-free, the valorization of waste materials, the exploitation of durable and recycled materials, using eco-friendly production processes, and the development of traceable fibers are also key factors. In my opinion, the biggest challenge would be to achieve a good balance between performance features and circularity and sustainability criteria, as I said, mainly in the case of technical textiles. So now let's move on to the main topic of this webinar, which is alternative fibers. And to start, I will speak about some concepts. One of them is recycling. In general, we can say that recycling aims to recover and reprocess waste and repurpose it into new products. In the textile context, textile waste is generally defined as any discarded textile material or products that don't fit for its original purpose. Textile waste can be divided into, I divided into three groups, depending on its origin, namely post-industrial waste generated during the manufacturing processes, mainly from the spinning and weaving process, and also from pieces of fabrics from cutting and sewing process that are also called scraps. Pre-consumer waste is considered finished products that could not be sold or used, including default goods. And post-consumer waste are the products that have been already used and are not considered or are considered not suitable for reuse. Moreover, waste created from other sectors can also be explored to create new textile fibers, and agricultural residues are one example of that. In general, we have four main types of textile recycling, namely mechanical recycling, thermomechanical, chemical, and biochemical. Mechanical recycling means processing textile waste into secondary raw material without significantly changing the polymer chemical structure of the fibers. And in this case, shredding of textile fabrics is performed to obtain fibers again. The quality of the fibers depends, of course, on the quality of the processed fabric, and depending on the obtained fiber quality, fibers are used to produce new yarns for knitting or weaving, usually in a specific amount in order to assure a good quality of the yarns. And the low quality of fibers are normally used in nonwovens and biocomposites. So through this process, all fibers can be processed through mechanical recycling. Regarding the thermomechanical process, materials are normally cut into small pieces and then melted to produce secondary thermoplastic granules to produce new fibers. Polyester recycled fibers obtained from PET bottles is the most well-known example produced from this recycling process. The chemical process involves several chemical processes, as I can say that, and the goal is to break down materials waste into their original monomers. To do that are used chemical substances and solvents, and based on this process type, regenerated cellulosic fibers such as lyocell and viscose can be obtained from cotton waste, for instance, and it is also possible to transform synthetic fibers into new synthetic fibers. This process method allows also the processing of fiber blends. It is required to separate individual materials through specific process and specific solvents. Due to the high number of variables of textile fabric characteristics like composition and color, transforming textile waste into new textile fibers is, in my opinion, a big challenge and the most desirable approach. In the biochemical process, enzymes are used instead of chemicals and solvents to decompose materials. So it requires controlled conditions and time for enzymes to work, and normally is associated with a lower environmental impact when compared to chemical process. However, biochemical process has a lower TRL, especially for synthetic fibers recycling. Bio-based expression is also is very common these days, mainly associated with bio-based synthetic fibers. Anyway, I would like to tell you that there are other fibers which are also bio-based, namely natural fibers, processed fibers based on natural materials such as regenerated cellulose, use microorganisms in the production of polymers, so BHB or bacterial cellulose are examples, and biosynthetic fibers produced from biologically produced materials are also examples of bio-based biosynthetic fibers. Indeed, the use of bio-based fiber is gaining attention as an alternative to fossil-based synthetic fibers such as polyester and nylon. So there are a lot of research work on this topic. To determine the bio-based content of products, two approaches can be used. So it's possible to determine the bio-based biomass content, or it's possible to determine the bio-based carbon content. Each approach has specific particularities, presenting advantage and disadvantage depending on the context that we are studying. In this slide, we can see some standards referring to the both approaches. I'm not going into the detail about this subject, but the main goal is to just to tell you that it's possible to measure the amount of bio-based content in a specific fiber. Compostability and biodegradability are also common current expressions, and we know that a bio-based material does not mean that is biodegradable. So I have here some definitions about these terms. So composting is a process where materials can be degraded under specific conditions and can be made industrial or home composting. Biodegradability is a process in which materials are metabolized through the action of microorganisms, and both processes depend on the conditions. So depends on the location, temperature, moisture, depends also on the specific environment, if it is in soil, seawater, sea river, and so on. As far as I know, there are not still standards applied for biosynthetic textiles to test biosynthetic textiles. The current certification labels are usually based on standards applied to plastics, as we can see in these standards. So I put here some examples of testing standards. As you can see, some of them applied to plastic materials or packaging. So we know that biodegradability is not a good end of life for a product, and the recycling is preferred. We know that, and it's European Union regulation drives towards recycling. But however, biodegradability makes sense for specific applications. For instance, for medical and hygienic textiles, so disposable materials for yet, and also for food packaging, for instance. Okay, in this slide we can see technical specifications of two labels related to this topic from TUV Austria. As we can see, they refer to biodegradability under composting conditions such as testing time, temperature, and relative humidity. And we can also see that are different values for industrial and home composting. Disintegration, compost quality, and physicochemical characterization of the test material are also performed for compostability analysis. So this is already applied, has been applied in some fiber cases for synthetic biosynthetic fibers, but in my opinion, this is a complex issue until now, I think, and there is a lot of work to be done in this area in order to clarify the compostability and biodegradability of the fibers, especially when we speak about biosynthetic fibers. Microplastics is another complex topic that is under investigation, even though there are already some standards to assess microplastics impact of the textiles, and here we can see two standards. So we know that it is a very challenging task to define if a product is sustainable or not, because there is no global standardization assessing methods or labeling. Instead of that, there are a lot of labels, tools, and guidelines addressing different criteria. Anyway, I tried to summarize the scope of eco-design, circular economy, and sustainability. So, the main principles of circular economy are, as we know, eliminating waste and pollution, regenerate nature, and make materials circulate. Eco-design involves the use of low environmental impact materials and processes, minimizing the use of resources, using durable and recyclable materials, and for specific cases, as I said before, biodegradable materials. So eco-design and circular economy have similar goals, so are correlated. These big expressions to achieve sustainable solutions. It's important. It is also important to weather or to consider social responsibility in terms of human rights, animal welfare, and also, of course, the economic viability. So it's a summary of what are the topics that influence sustainability of a material or a product. Specifically speaking about the sustainability of fibers, or the main concerns in this area. The major concerns regarding synthetic fibers production are related to the chemicals used, which are mainly produced from non-renewable sources, climate change, greenhouse gas emissions, and water pollutions. Microplastics, as I've already mentioned, is also an issue. Regarding cotton fibers, social issues regarding human rights, such as child and forced work, pesticide exposure, soil degradation, and one big concern that is water scarcity are the main concerns. To respond to these concerns, many labels are addressing. In case of cotton, there are organic cotton, and there are recently organic and regenerative cotton. So, and the main goal is to respond to these concerns. Concerning man-made cellulosic fibers, deforestation, illegal logging, biodiversity loss, climate change, and indigenous communities issues are the main concerns. And regarding wool fibers, labor-related land degradation from grazing, biodiversity loss, no muzzling, and other animal welfare are the main concerns. This slide tries to summarize the main research areas under the topics related to the sustainability of fibers that I've already mentioned before. One of the main topic is the exploitation of renewable sources. And under this topic, the focus is to make natural fibers more sustainable through organic and regenerative cultures, explore new plants for fibers extraction, and use agricultural residues, and also ensure that animal protection practices are followed. And other research area is to explore the mechanical process, recycling process to obtain new fibers. Um, Under this topic, also new cellulosic fibers are being developed based on textile waste and from other waste sources, such as uh, agricultural residues, newer and more ecological processes, and also being developed to achieve new cellulosic fibers, um, some of them similar to viscose, or some of them similar to lyocell fibers. And the other possibility is the development of the bacterial cellulose. Develop bio-based synthetic fibers that are biodegradable in different environments and that are compostable at home or industrial conditions. So controlled conditions are also important topics. And the valorization of synthetic fibers waste is also another important issue. So how we valorize the waste, or how we can valorize this waste, exploring different recycling technologies and different sources of waste. As I said, textile to textile is the most challenging task, but is the most wanted process to do to environmental impact issues. Obtaining traceable fibers is also a very key factor in order to prevent counterfeiting, and enable the implementation of the digital product process. So it can be useful, for instance, to know the materials of a specific product and whether they are virgin fibers or if they have already been recycled. So now I will show you, I will identify some recent fiber developments with the sustainability criteria. In this slide, we have the hemp fibers value chain. Industrial hemp fibers are a very interesting raw material for the textile industry because have similar properties to flax, and so is a strong, a mechanical strong fiber. And some studies indicate that hemp crops are good absorbers of CO2 from the atmosphere, and can also absorb metals from the soil, and also require less water and pesticides than other traditional natural fibers, such as cotton or flax. Anyway, for me, the environmental impact of this fiber is not very clear enough until now. So further studies are required to clarify the sustainability of the type of this fiber type. In this slide, we can see the global value chain. The production of hemp fibers has some similarities to flax production chain. Both fibers come from the stem of the plants, although until now hemp processing presents additional challenges. I'm not going to detail in each step of the process. So my idea is just to highlight that although these fibers are not new, there are still a lot of bottlenecks to overcome. And the main challenges are related to limited knowledge of the on hemp cultivation, the extraction of the fibers from the plants, and also the lack of interconnection of between the players in the value chain. Just to give you an idea, for instance, the sowing density in hemp cultivation and the variety of the seed influences the diameter of the hemp stems, which will determine the process technology that can be used to process these fibers, these stems, and also the quality of the fibers that can be obtained with them. So it's a complex process. I would like also to tell you that rating is it is a very important step, and the goal of this process is to leave the stalk on the field after the cutting for some weeks under the action of microorganisms and the moisture. So the goal is to facilitate the separation and individualization of the fibers in further steps. The stem is the part of the plant that is between the roots and the flower and the leaf. It contains a wood core in the middle of the stem. And the wood part of this stem is mainly used for insulation and for gardening, for instance. So the selection of the seed variety, cultivation and harvesting methods, rating conditions, technologies and methods involved in the transformation of the plant into textile fibers have a huge influence on the parameters and quality of fibers. So, for instance, using a decorticating equipment, short fibers are obtained. Using a breaking and a sketching line, very long fibers can be obtained. So, there are different qualities of fibers depending on the process used to extract and process the fibers. CITEV is working on this subject. We have a national project called BIT, and biomaterials is one of the topics. And within this, there is an initiative that aims to boost the agriculture and textile sectors to produce natural fibers, including hemp and flax fibers also. Also, banana and pineapple fibers are interesting natural fibers because they come from leaves of the plants and are agricultural residues. In the case of the banana fibers, they are obtained from a pseudo stem because the stem of the plant is made by the plant leaves central part. And there are also bottlenecks in fibers extraction from these leaves. And the main bottlenecks are also related to the fiber extraction because until now requires many manual operations. Kapok and milkweed fibers are other examples of natural fibers obtained from, in this case, from plant seeds. Kapok is not new, but milkweed is quite recent, I think. Both fibers are very thin, have a short length and a soft touch. For instance, normally kapok is used in blends with other fibers. And the example provided by this brand of milkweed was for nonwovens applications. To answer the concerns of cotton production and aiming to reduce the variables of the natural fibers, because the quality of the natural fibers depends on the wide range of factors like weather. There is under development the cultivation of cotton plants and fibers also under controlled conditions, so in indoor and through hydroponic techniques. As you can see in the image, providing color to the fiber as an original property is also under investigation. It's not easy to achieve this, but I know that is under investigation. And the principle of hydroponic technology consists of placing the seeds in a water-based solution, and plants will grow being fed by the controlled water-based solution. So we hope could be a promising approach. In this slide, we have a summary of recent cellulosic fibers brands produced with post-industrial or post-consumer cotton wastes or based on agri residues and or special process. Some of them are composed, for instance, of 100% cellulose waste, and some of them have a small specific percentage of recycled material. Some of them are already in the market, and some of them are still under investigations. In addition, I can say that some of the examples of these fibers, the properties of these fibers are similar to lyocell fibers, and others are similar to viscose. But as in general, lyocell fibers are considered more eco-friendly than viscose fibers, mainly due to be associated a more eco-friendly production process because use a closed loop process. And the biggest, I think, the biggest challenge in this area is to obtain a good and mechanical strength, good mechanical strength and stable at dry and wet conditions. Okay, so there is also under investigation bacterial cellulose, and here I have a brand as an example of that. In this slide, we have examples of brands of recycled polyester fibers obtained from PET bottles or other residues through thermomechanical process or using chemical process. And there is also a solution that is being promoted as obtained from CO2. Here we have brands of recycled polyamides and elastane fibers. In the case of polyamides, there are also solutions obtained through thermomechanical process and also from chemical processes. And here we have examples of brands of polyamides, polyester, and elastane fibers promoted as bio-based fibers. Usually the brands say that the amount of bio-based content on the fiber or mention a certification or a label related with the scope. Under this topic, there is also PLA. There are some brands of these fibers that are derived from renewable sources. PLA is considered compostable under industrial conditions, meaning it can break it down into natural components within a controlled composting environment, but it's not compostable, for instance, in home composters, and it's not proven that it's biodegradable in seawater. So it's important, the information that brands, in my opinion, should provide. There are also brands of synthetic fibers with the additives to speed up the degradation process. Some of them mention the time and conditions of their degradation, but there are cases where the published data is not very clear. So, as I mentioned earlier, stating that the biosynthetic fiber is biodegradable without additional data, it's not enough, and it's probably greenwashing. More so, there are also or recently developed or are under development new polymers, PHB and proteins based fibers are being developed using microorganisms, and I put here also two brands that are working on this subject. As I've already mentioned before, the implementation of DPP will require the traceability of textile materials. On this slide, there are technological solutions on the market. Fiber Trace and Aware are designed to trace and authenticate fibers at every stage of the supply chain, from raw material to finished product. They apply a specific materials to the fibers, and they can be detected by a scanner throughout the life cycle of the product. ALIXA technology has the same objective, but use a DNA based traceability and verification system. The last slide refers to fiber categorization adopted by H&M brand, which is based on the list of preferred materials published by Textile Exchange some years ago. And as we can see, regarding cotton fibers, recycled cotton and regenerative organic cotton certified are the preferred solutions, and they are classified as class A. For cellulosic man-made fibers, the best classification is for certified fibers made from recycled cellulose and agricultural waste. Lyocell being associated with a process that has a lower environmental impact than viscose had better classification than viscose or modal. In the case of polyesters, the preference is given to certified recycled fibers from textile to textile. In case of polyamides, acrylics, and elastanes, the preference is given to certified post-consumer recycled fibers. So we have here the post-consumer recycled fibers in class A, and the pre-consumer recycled fibers, for instance, in polyester and elastane, in class B. Um, to finish, I would like to say that CITEV is working in practically in all areas. So please don't hesitate to contact us if you think we can help you with your work in some way. So now I think I'm available to answer any questions you may have. I I didn't see
Yes, I will
the chat.
permit the camera and microphones for everyone. So um, please feel free also to write on the chat as well. I believe almost everyone have already microphone and camera, so please feel free. If we don't have questions or anything to add.
No questions.
I think everyone, I think we can finish this session. And of course, you have Lucia's contact if you have further questions or further interests in CTAP as well. Thank you very much for being here today and follow this session. And if you have any questions about the next sessions, please find the next sessions in Ways to Be a Comp project website. And if you have any other questions about the sessions, please also contact us for further information or further assistance. Thank you, Lucia. And thank you,
Thank you.
everyone.
Thank you all.